Okay, so let's go to the next slide. So what are the advantages and disadvantages of a linked list? The advantage, one of the advantages is dynamic sizing. In this case, elements can easily grow or shrink in size as elements are inserted or removed. Um, and then we have another advantage of constant time insertion. So inserting or deleting an element at the beginning of a list is much easier when it comes to linked lists, because if you have the reference to the head, of course, and then there is that aspect of efficient memory usage. Like when we were handling arrays in C, when you allocate memory, maybe you would allocate a memory for an array with 10 elements. And let's say you end up not using that memory, you end up not using that memory you had allocated to store the 10 elements. Maybe you store like 5. So you see, you are wasting like you are wasting like 5 memory space. I don't know, like you'll be wasting that. But in cases of linked lists, you find that since the values are scattered in memory, there is efficient memory usage. And then for the disadvantages, we have like random access. Uh, Random access, this comes in like in an array, when you're accessing an array value at a specific index 1, you'll just refer to that array and then put the index that you want to access the value. As for linked list, you'll have to traverse the previous elements before getting to a certain value that you want to access. So that's one disadvantage that comes with linked lists. And number two, uh, in as much as there is efficient memory usage in linked lists, each node in a linked list carries an extra overhead due to the need for references slash pointers. Like you have the previous maybe and the next references. So you find that each node will carry this extra memory overhead. And then again, there is the aspect of more complex operations. Like I was saying at point number one, like for an array, you'll just need to reference to that array and a specific index that you want to access its value. But for linked list, you'll have to traverse the entire linked list until not the entire the linked list until you get to that specific value you want to get to. Okay. So we get to types of linked lists. So we have singly linked lists where each node has data and a reference to the next node, like as shown in this picture here. This is the most simplest type of linked list, and it's memory efficient given the aspect that I had mentioned previously. It like say if it was a double linked list, it would have a previous reference here, and that will be an extra memory to contain that reference. So how do we create a single linked list. So in this example, sorry, in this example, we are going to use Python to elaborate this example. I hope you can all see my code. So in this case, we have a class node which will initialize it when it's instantiated. It comes with the data field and also the next. So in this case, when this class is instantiated, the data will be the data that's held here. And then the next, since we don't have a reference to the next node at that point, but this we can define later, we refer it to as none. So, and then we have now another class called linked lists. Here, when we initialize it with the value of self.head, which is none at the moment because, yeah. And then, so when we want to create an empty linked list, what do we do? Like we try and instantiate the linked list class. So here we have my list equals to linked lists. Now here we are instantiating, we're creating an object from the linked list class. And then now to add the first node, so we'll have first, and then we instantiate again the node class, and then give it a value of 10 for the data. And then now finally we link it with the head node. So my list dot head, you remember my list here, we had instantiated an object called my list. So my list dot head, will give it a value of first. Will, yeah. Okay, so we'll go again. I'll elaborate this again further using my some code that I just wrote for this purpose. So let's go to double linked lists. In double linked lists, each node has data, a reference to the next node, and a reference to the previous node. This allows easy traversal in both directions. So in this case, we have the head node, and maybe this is the tail, right? And then, as we say, the head for the previous, it will point to null since there is no previous node before it. And then the next node will be B, and as you can see, it will have a previous reference to the previous node, and then it will have a reference to the next node again, and that goes on until maybe the last node, the tail, which for the tail, the next reference will be null since there is no node after it. So this is an example on how we'll go about creating a double linked list. So here, the node structure, we'll have a class node, which when we instantiate it, it should come with a data field, a next, and a previous property. Yeah. And then when we instantiate it at first, because it has no, okay, so the next value should point to null, and then the previous should point to none. And then now we go ahead here, sorry, we go ahead here to create an empty linked list. So now this we are trying to create a class linked list, which will have, which when we instantiate it will have a property of head, which by default is none. And then now let's we get to the point where we test the code. Here we create an empty linked list. So we create an empty linked list called an empty linked list object called my list. So we've referred to the linked list, and then to add the first node, we refer to we instantiate the class node and give it a value of 10. And then now linking the head with the node like we did before. So it comes like this. We have my list dot head equals to first. Here I tried to add, sorry, sorry. Okay, here I tried to add you remember the first object we created from of the node class. So first dot next will point to second, and that's pretty much it. So going now to the head. That's the first node. So as you can see here, head, and the head itself again uh, in a circular linked list will point to the tail. So as you can see here, the head has a reference to the tail, which is at maybe pointer reference 333, right? So we have 333 as the previous reference in the head node. And then the head node will have again a value of 1. And then for the pointer to the next reference, it will be pointer to the next node, that is, uh, it will be 113. So as you can see here, it's 113. And then this goes on and goes on until now the tail. Now, when you get to the tail, you can see now the pointer to the next node. For the tail node, you see it points back to the head. Now that's how now circular linked list work, and this applies to singly and doubly linked list. Like it's similar. It's similar in singly. Okay, circular linked list. They're similar to singly and or doubly linked list, but the last node or the points to the first node. And again, now the first node in this case, since it's a doubly linked list, will point to the tail. Okay, so here we are going to tackle now creating a doubly linked list. and in this case we are using a singly linked list, but a double linked list made of a singly linked list. I don't know if I'm making sense. Yeah. So here we'll have a node um, that will have a node class, and then when we instantiate it with properties such as data and next. And then we also have a class linked list, which when we instantiate it, we give it a property of head. We'll have a property of head. And then we go ahead to create an empty linked list. So now bringing about the concept of doubly linked lists, for this case in singly linked list. So we'll have pointer to the first node. Okay, we'll add a first node, which where we'll instantiate the node class and give it a value of 10. And then we link again this with the head node. Okay, we link this with the head node. Like, okay, I think I skipped something. Like we had created the class my list, right? I'd created an object called my list. So I'll go ahead and refer to this my list and then to its head property and give it the value of first. And then later, I link now the next of the node with the head. So this is the first node, right? The first node. So first dot next, I give it the value of my list dot head. You remember we were now the next shouldn't be null in cases of the next shouldn't be null for the tail in cases of doubly linked lists and no circular linked lists. So the first dot next will will make it refer to my list dot head, the my list dot head we had created here. So when it comes to adding the second node, we'll have an object called second where we'll instantiate the node class. We'll give it a value of 20. So linking it again with the first node that we had created earlier. So first dot next, we make it point to second. Remember again, before we had it point to we had it refer to the my list dot head. Now in this case, since we are adding a second node, first dot next, we'll have it point to the second node that we are creating. And then lastly now, the second dot next, since it's a circular linked list, we'll have it point to the head. Yeah. So we have some basic operations when it comes to linked lists. Um, yeah, I'll stop sharing so that I can share now the code with you, which tackles these basic operations such as insertion, traversal, which is going through a linked list and like accessing all data elements in a linked list. And then there is deletion, there is search. Maybe you want to search for a certain value. You can also do operations like reversing a list, swapping nodes. Say you want to swap this node and the other node in a list. And maybe lastly, getting the length which is now the number of the nodes in a linked list. So let me stop sharing these slides and now let's get to the terminal. So far, do you have any questions? I think I've been talking a lot and I haven't asked people for if they have any questions. Hello? I've gone pretty fast.
Uko tu sawa, tunafuatilia.
Say tunacheka tu. Hey, okay. So let me stop sharing the slides and now I'll come to sharing now my terminal. Okay. I don't know if you can see now my terminal. So I had created this linked lists, this linked list.py script. So for the purpose of demonstration and maybe yeah some easy understanding, I've chosen to go with singly linked lists. So yeah, I'll be performing these operations on a singly linked list. So as I had mentioned, in the creation of a singly linked list, we'll have a class node which will set it to instantiate and have values such as data and next. And then we'll have a class linked list, which when instantiated will come with the value head, right? And then now these are the functions, the basic operations that I was talking about. So when it comes to insertion, you can choose to insert at the beginning. You can choose to insert a value at the end of a linked list. You can choose to insert at a certain position, right? So I think I'll just go through the insert at the beginning. Okay. So at the insert at the beginning, now you are inserting a node at the beginning of a linked list. And now you'll go ahead now and create a new node object. And then you pass parameters such as data. That is now the value that you want to store in the node. And then in this object that you've created, the new node, oh sorry, I'm being told that you can't see my screen. Sorry. Okay. Sorry, I didn't realize that. Just a minute. Okay, let me stop sharing and share again. Okay, what can you see now? Sorry, I'm on.
Umeshare
Okay, na share na window. I'm sharing the window.
share ndani screen tu.
So imagine na screen haionyeshi anything. No, ama ni share to the entire screen. Nashanga, what's happening? Acha tujaribu tena share. Okay, entire screen. Okay. Let me. Okay. Can you see my terminal? Hello.
Yeah, sasa iko sawa.
Okay. So I'd gone ahead to create a Python script, um, which will elaborate, which will show you, which I'll use to show you the linked lists, basic operations on linked lists. Yeah. So in this case, I'm using a singly linked list to elaborate these basic operations. So I'd gone ahead. A, I'd created a class called Node. The class called Node, when instantiated, it will have a self.data field. It will have a self.next property again. And then next, we go ahead and create a class called linked list. In the class linked list, um, when instantiated, it will have a self.head property, a self property called head. And then now we were talking about the basic operations on linked lists. Sorry. So we were talking about the basic operations on linked lists. In this case, insertion. And I was saying you can choose to insert another node at the beginning of a linked list. You can choose to insert at the end, and also you can choose to insert at a specific position, right? And then now, so in the case where you want to insert at the beginning, we'll first need to create the node that we want to insert, right? So we go ahead and create a new node object from the class node, and then this node will have the property, will have the parameter data passed to it. So this data will be stored in the node as the data element. And then we'll refer to the new node object again, and this time we are referring to its next property, where we'll assign it, where we'll make it point to the self dot head, which in this case, which in this case, like if you had a linked list, the value the if you had a linked list that you're trying to insert a value to, you'll be given the pointer to the head. So you're trying to insert at the beginning. So now for the new node dot next, just a minute. Okay. Okay. Am I audible? Sorry.
Yeah, uko sawa.
Okay. So yeah, we've pointed now the new node dot next to self dot head, and
Hebu
then now
niko na
yes,
swali
yes.
pale juu kwa ukicreate hiyo class ya linked list, class ya node huko juu haufai kupass in pia hiyo next kwa hiyo as a parameter after data.
Okay. Ukiinsert, unaona ukiinsert your next,
Eh,
like ukicreate your node, right? Automatically like ukiinstantiate inakuja ka next ikiwa none. Sawa. And
oh,
then ikikuja next ikiwa none,
mm,
so like hapa ka unaona hapa kwa insert at the beginning we have new node, right? Tumeinstantiate your nini, your the node class, right? And then now the new node dot next, since tunajaribu kuinsert already, tuko na a linked list already yenye ina exist, sawa.
mm,
And then umepewa reference to that linked list yenye ina exist, sawa.
yeah,
So hii new node dot next, since una try kuiweka mbele ya hiyo linked list, utaiweka ipoint to self dot head, ile nini hii sasa, hii linked list yenye already uko nayo, so the head value like the head reference unaiweka hapo sasa ipoint to hiyo, and then now the self dot head unaifanya ikue hiyo node mpya umecreate. Jili sahisi ndio imekuja ikakuwa ndio ya kwanza.
ndio ya kwanza. Oh, okay, understood.
Mnanielewa ama naongea Greek? Okay. So we have also insert at end. Hii sasa tutaweka at the end of a linked list, right? So we go ahead with the same procedure. Tuna create a new object called new node. Alafu tunasema if not, ka ulikuwa ka like yo reference ya hiyo linked list ulikuwa umepatiwa, right? I see the head, right? Like see, no, it's none, iko null, kumaanisha like hii linked list yes iko like, lakini haina head or anything, it's just empty, it's an empty linked list. So jili umecreate a new node na unatry kuinsert at the end na umepata hii linked list by the way iko empty, so you make this new node become the head. Sawa. Hello.
Yep, yep. Waendelea.
If
Sawa.
that's not the case, if that's not the case, like self.ed is not none, is not null, unaweka now the current, like una create a variable unaita current, unasema current itakuwa self.head, and then una iterate now through the linked list now, that is the current, while current dot next. So hapo unasema like while current dot next is not null, like hadi uende hadi huko mwisho, utaenda tu ukisonga unaweka current equals to current dot next until the point that utafika upate current dot next is null. So at that point ukifika hapo you'll exit this while loop, and when you exit it, now you'll have the current, now you'll have now this current dot next value which points to null, uiweke point to the new node,
Mm,
right? Na hapo
yep.
sasa hiyo new node yenye ulicreate, that new node object you had created, itakuja to the last part of your linked list.
Nikijaribu kukumbuka hiyo neno yenye tumeweka huko mwisho inafaa ipoint to null.
Yeah. unaona saa like ndio nilikuwa nakwambia,
Mm.
unaona hapa kwa hii node right,
Mm.
ukiinstantiate at first ina point automatically to null, hii none, so
Mm.
unaona. So
Eh,
since ilikuwa isha point to none, there is no need that useme tena hii
kuongeza
new
line
node
nyingine
dot
hapo.
next equals to none, zili already iko equals to none.
Sawa.
And then you can choose to insert at a particular position. So in this case, at a particular position unapass sasa yourself. So yourself ni the linked list itself, your the linked list object, and then data yenye unataka kuinsert, and then the position you want to insert it. So in this case, we'll go again and instantiate the node class where we'll store, we'll have it now, the new node, we'll create a new node object from the node class, and then if position yenye hiyo parameter yenye umepeana hapa equals to 0. Okay, if position equals to 0, unasema new node dot next point to now the self dot head. Sasa ile reference ulikuwa umepewa ya the linked list right, since hii reference ukipewa ina pointing to the head of the linked list, so utaipointisha hapo, and then now the self dot head ya hiyo linked list yenye ulikuwa umepewa uifanye point to the new node, so ikuwe nikaa sasa hii new node imekuja at position 0 which is the start of the linked list. Else, if position is not equals to 0, una create a nini, you create a variable called current, and then unaipea current equals to self dot head. Now this is the reference to the linked lists at the head position of a linked list, right? And then you say, okay, hii underscore ni like tu ya kuiterate, so like for underscore ama for I in range, position -1. Why are we subtracting -1? Jili, how range works, unajua range starts automatically at position 0 and then inaenda hadi mali unataka, so hapa hata ungeweka tu if we had 0, okay, if we had like 0 here, hii inakaa tu inamaanisha hivi right, and then if current is none, now this variable you had created here, if current is none, that will mean that this linked list it's empty right, una return zile, hakuna venye unaweza like una exit sasa hii loop, una hakuna venye unaweza insert at a particular position for an empty linked list, jili yenyewe hata haina values, so kuinsert itakuwa ngumu. Ka that's not the case, you loop and then you say current equals, you keep referring to the next, to the next, to the next, and then until now you've gone through that loop, umeenda through hii loop ukafika that position yenye unataka, so hapo itakuwa imesha loop hadi ikafika mahali unataka. So hapa sasa next utasema, so for the new node dot next equals to current dot next, and then now the current dot next, since unajua venye sasa venye uliloop hapa ikakuwa umeloop hadi ukafika at that position, ulifika to the position that you want to get to. That's why we had subtracted this one here. Ndio like hii loop ifike hadi to like a previous position you want to target, not the position you want to target itself. Ifike hadi hapo mali inataka the previous, alafu sasa ndio by the time ina terminate inafika to the position you want it to get to. And then now you put your current dot next, you point now to the new node. Let me just close this so that I can now run this script. Muone sasa muone like what I'm talking about. So when you run this script inakuletea hizo options, like in this case now we can start with insert at the beginning. So let's pick option 1. The element we want to insert at the beginning, we want to insert a value of 10. And let's now print now the linked list that we just inserted the value at. So we select 7, and as you can see here, hii linked list initially it was empty. So being like initially zilikiinstantiatiwa inainstantiatiwa as an empty linked list, and then we have gone ahead and said we want to insert at the beginning of that linked list. So the value 10 has been inserted at the beginning, right? We can choose to insert at end. So number 2, insert at end. Hii terminal yangu mnaona vizuri ama niongeze font?
Iko sawa, iko sawa.
Can add, can choose to add.
Iko sawa tu kabisa, tunaona vizuri.
Mnaona? Okay. So the element that we want to insert at the end, let's say we want to insert 20, right? And now let's display this linked list that we've just inserted another node with the value 20 in it. So print, and as you can see tumeongeza 20 at the end of that linked list, na hii 20 hii node ina carry 20 tumeifanya point to none, right?
Yep. Reverse your linked list.
Ngoja tutafika hapo mva. And then now number 3, now we want to insert at a certain position. So what element do you want to insert? Let's say 40. And then what position do we want to insert it? Remember, this is position 0 and this is 1. Maybe we want to insert it at position 1. Where ama tuweke hapa kwa 0. Sawa. Tuweke at 0. Katikati.
Like at 1.
Okay, katikati itakuwa at 1. Okay. So let's now print that linked list. And as you can see, hiyo 40 imekuja katikati, replace 20 ikaingia in its position, alafu ikasukuma 20 mbele. So sijui nirudi kwa code ama tuendelee. Are you enjoying this? Hii console yangu yenye hapa tu vitu na run hapa. So sijui niende niwe elaborate pia venye sasa hii code ya delete at the beginning, delete at the end, pia delete at a certain position, ama kwanza niwaonyeshe hapa then we go to the code.
Any tu iko sawa.
Okay, so say we want to delete at the beginning of this linked list. So number 4, tukiprint naona imetoa, what was the value?
10.
Imetoa 10. Yeah. Tukitaka tukitaka kudelete at the end, we choose option 5, and then now let's print it. Let's print the linked list again, and as you can see imetoa 20, which was at the end. And then maybe we want to delete at position 6. We want to delete a position. We choose option 6. The position that we want to delete, since our since our linked list has only one item, we'll choose 0. So let's print it again and see. Then you can see the linked list, now it's empty. That's why it's returning a none. So let's go and check the code for this. So for the delete at the beginning, hii ndio iko rahisi, haina mambo mingi. So if not self-dotted, now if this linked list is empty, you can't delete an empty linked list. So tuta return to exit your nini. And then ka that's not the case, unafanya self.head equals to self.head next. Self.head next. So hapa, like if you had a linked list, iko na values ka 10, and then the next value is 20 on the next node, and you want to delete now this node containing 10. So the self.head unaifanya ipoint to its next node, and then that way utakuwa nika umedelete your value at the beginning. Okay, so to delete at the end, yeah, like hapa kwanza si tunaangalia ka hiyo linked list iko empty. Ka iko empty, we return. And then ukipata here the next value, ukipata the pointer to the next value is not none, like iko na value, unaichange, unaiweka self.head equals to none. Hello, mnanisikia ama nimewapoteza? Okay, so venye nasema sasa, hapa ndo nilikuwa, so you've checked if the linked list is empty, ukapata if it's empty, and then you've gone ahead to check for the next node. If it's none or not. If it's none, you go ahead and say you point now the self.head to none. Jili hapo itamaanisha since it's pointing to a next value that's none, the node that you should delete now, it's the node that you are referring to at the moment, the self.head. Jili haina a next value, so hiyo ndio the node that you should delete. If these two are not the cases, unasema like current equal, you create another variable called current, and current equals to self.head. You have it hold that value, and so while current.next in exists, no, like it's not none. You still continue now pointing the current. You still now you change the current value to the current.next. So hapo una iterate tu kisonga until where you reach the point that the current.next is none. So hapo ukifika hapo itamaanisha now the node to the delete ni current.next, right? And then in a case where you want to delete at a certain position, hapo umeangalia if that linked list is not, if it's empty, una exit, huwezi delete pia a node in an empty linked list. And then again you go ahead and check if that position that you want to delete, is it equals to 0? If it's equals to 0, this means you're deleting at the beginning of a linked list. So you'll have now the self.head point now to the, you'll have the self.head hold the value in the self.head.next, now the next node value, alafu hapo utakuwa umedelete at that position, hiyo position ya kwanza. If that's not the case, if position is not equals to 0, if the position is not equals to 0, you now have this value, this variable current hold the self.head value, the node at that point, and then now you iterate now through the linked lists until you get to that. Okay, first you check if the current that you just the current variable, if it's holding a none or the current.next is none. This means that tuseme maybe you are given delete at position 5, and then you found that this linked list is empty, ama like maybe it's holding only one value at position 0 na maybe umepewa position 5. So this checks that. Ikipata like that's the case, like maybe you're trying to delete at position 5 and then that node, those nodes there, maybe there is only one node, you can't do that operation, otherwise it will throw to my error. So una exit loop. If that's not the case, you go ahead, you continue pointing to current.next, and until ifike kwa ile position sasa previous ya yenye unataka kudelete. And then now in that case sasa utasema current.next zilikuwa the previous value, unaisema sasa the next value. So hapo utakuwa ume loop hadi ukafika to the previous position in which you want to delete. Alafu sasa hapa the current.next of the previous position sasa ipoint to your current.next. So hiyo sasa ndio itakuwa ile position yenye unataka current.next itakuwa a null value since iko like not a null value, itakuwa like ina point to imeruka sasa your ile node yenye unataka kudelete, but initially ingekuwa current.next ina point to ina point to now your node, but now umeivukisha sasa, ina point to the next node, so itaruka hiyo node yenye unataka kudelete. Sasa in that case itakuwa imedelete at that particular position. And then now printing a linked list. Okay. Let me go back to the slides. Printing a linked list is a form of traversing. It's a form of traversal. So in this entire time tumekuwa tukiprint a linked list, we've been traversing. We've been traversing this linked lists, right? Hizo like venye nilikuwa na press option 7 and then inaleta inaonyesha we've been traversing hii linked list yetu, and then we are displaying the values. So like here you can have it hold you can have a variable hold the linked list, the head of the linked list, right? And then now you go and say while current iende ikiprint the current.data, right? So itaenda ikiendelea hivyo, and then now you change the value of the current, point now to the next, refer to the next node. So itaenda ikiprint hivyo hadi ifike mali current.next, yani ifike mali current is none. So hapo ndio utaona, ndio hapo mwisho ulikuwa unaona ina print none. Tulikuwa tumeweka iprint none. Okay. Okay, another operation will be searching for an element. Maybe you want to search for a certain value in a linked list. Say uko na linked list and unashuku maybe ina contain node yenye iko na value, maybe a value of 7, right? So ndio ufanye hii search operation, we have now this function of searching a linked list. So in this case, the key is the value that you want to search for. So hapa now una create a variable called current, unaifanya hold the value of the self.head, alafu kwanza tunaanza tunasema hii position nimeiweka hapa ndio tuende tukiimplement. Ndio like if you are searching for a value number 7, right? Hii position itaenda until we get that value, inafaa increment and then to return now the position, right? Ya hiyo value. So while current, if current.data equals to key, right? Hiyo data yenye hiyo tuna traverse now the linked list, and then we are trying to see if this value will equate to the key that we are searching for. We should return the position. So if maybe you are searching for 7, na 7 iko like it's at the first it's the first element of that. No, 7 is held in the first node of that linked list. So utapata nika hapa return position equals to 0. Else, if that's not the case, tunasema current iende to the next now node, and then we increment the position, and this goes on until like your linked lists tufike kwa tail huko mwisho. Kaa tutapata anything, we return -1, meaning hatujapata anything. And then now kuna function ya reverse a linked list. So hizi tu ni like the basic operations, like when you encounter linked lists, kuna some operations that you can do to that linked list hivyo. Na hizi vitu hata sengine zinakujanga kwa interviews, unaulizwa inakuja kaa problem una solve where you are required to maybe reverse a linked list, you are required, yeah, ni hizo tu vitu tu za kutest ka you know things, data structure, hizo data structures and algorithms, yeah. So in a case where we are reversing a linked list, we create a variable and then we set it to hold a value of none. And then now the current and we create another variable and then we get it to hold a value, the value of the head of the linked list. And then here we go ahead and say, while current, now we iterate now through the linked list. And while we are iterating through the linked list, we create another variable called the next node. And the next node will have it hold the current dot next value. And then the current dot next value should point to the previous. The current dot next value should hold the previous node element, right? Which we had earlier set to none. So unajua, like venye tumesema kwa single linked list, the last value will hold a null value, a none value, right? So tukisema current dot next, tukisema the previous, no. Tukisema current dot next equals to previous, hapa nikaa tumeiweka tu like ikisonga songa hivyo mwisho ikuje mwisho, like the first element point to none and then iende ikisonga songa hivyo mwisho tena. Okay. Hello. Mnanisikia? Nasikia nimenyamaza sana, niko peke yangu.
Tukosa watu wameanza kudisappear.
Oh, ni masaa. Okay, let me hurry up and wind up. I think I'll share this mwangalie tena vizuri. Okay. So so we are saying, so tutaendelea tu hivyo, like the current dot next kwanza ipoint to none and then tuendelee sasa the previous tuifanye ipoint now to the current and then the current tuipe value ya the next node and then while we continue with the loop hiyo ya the while current, by the end utapata like hii list imeji reverse. And then kuna hiyo tena nini ya kuswap nodes. Hii ni refu. Okay, acha kwanza niruke hiyo tuende kwa get length. Like I had said, getting the length maybe of a linked list is like trying to get the number of nodes in that linked list, right? So hapa like tumesema length equals to 0 and then we've said current to create a variable, another variable called current. Sema acha I point to the head of that linked list, right? And then we are saying while current iende ikiongezea length by 1. And then here as it does that, tufanye current hold the next node, right? And then ikiendelea hivyo until it gets to a point where current equals to none, we would have gotten to the end of the linked list and that way tutakuwa tumepata the number of the nodes in that linked list. And then sasa acha turudi kwa hii ama niwaonyeshe kwanza, acha kwanza nisiwabo. Acha kwanza tuende tuangalie sasa hii nini ya kuprint, like venye nimewambia, hiyo tumekuwa all through tukitraverse through a linked list and then we are printing its values. So let me just demonstrate the search linked lists. So what element, okay, in this case nini kwanza, acha kwanza, okay. Okay, you'll see that the element was not found because linked list yenye ilikuwa the object that was instantiated from the linked list, it's an empty linked list, so haina value. So hata ukisearch 8 na una search 8 na haiko, hautakuwa umetafuta kitu. So let's insert something in our linked list. So we'll go ahead and insert 8. And then after inserting 8, let's search for this 8 again, just to test that our search linked list is working. We'll go and search, and then we'll search for number 8. And then you'll see that the element was found at position 0. Because now we had an empty linked list, and when we added number 8, it went to position 0. And then now, for the purpose of demonstrating reversing a linked list, let's insert another value at the end. So number 2, let's insert number 2, let's insert number 3 rather. And then now let's print just this linked list so that we can see where everything is at. You can see it's 8 and 3. And now let's try to reverse this linked list. And then now let's print again. You can see mbeleni ilikuwa 8 3, now it's 3 8 3. Hiyo the linked list has been reversed to be the other way around. So acha nirudi sasa niwaonyeshe hii ya kuswap nodes. That's now the last item in our agenda. And then now I open room for questions. So let's exit. So when now we are swapping nodes, we have this function swap nodes. And then, like I said, the self refers to the linked list itself, since this is a function within the class linked list. No, this self is the object. Okay. And then we have this position that we want to swap from position maybe 1 to position 2. So by any chance mtu ameweka maybe anataka kuswap from position 1 to position 2 na unapata values za position 1 and 2 they are the same, hakuna venye unaweza swap the same thing. So hiyo tuna exit, tunatoka kwa hiyo nini, kuna any action being done there. And then now, so the next thing, if that's not the case, mentioned earlier, so tuna go ahead now to find the nodes at positions, right? The positions mentioned. So tuna instantiate these variables, previous one and current one, alafu moja tunaiweka point to none, I hold none, a none value, and then hii ingine tunaiweka hold now the head of the linked list, right? The node that's at the head. And then now we go again. Now we loop. We loop. So while we are looping through the various, we are traversing now the linked list. Tunaangalia tena hii current one ka is none. Hapa inamaanisha that's an empty linked list again, so tutahave ku return tutoke. So if that's not the case, ka hiyo linked list si empty, hii previous one you remember we had made it refer to hold a none value, tunaiset equals to now the head, the current one, the node held at current one. Alafu tena tunasema sasa tuna loop tena the current one ikwe ipoint now hold the next node. And then we do this until we get maybe to position 1. Alafu pia hapa tena tunatafuta sasa, si unaona hapa like tulikuwa tumesema current one it's at 1, but utapata by the time we are finishing, hii current one imekuja ikakuwa now the node itself that we want to swap, maybe yenye iko at position 1, right? Then we do the same to get the node that's at position 2. And then now here, we go ahead and say, if previous one is not null, like if previous one, you remember these values that we had set, these variables that we had set earlier. So after iterating, hizi vitu zilienda tu zikijinini. So hii previous one ina hold now reference now to ile node yenye iko mbele ya hiyo node yenye unataka at position maybe 1. Alafu hii previous 2 nayo ina hold value, ina hold node yenye unataka, and no, the previous now node that's at position, the previous node that's before the node that you want at position 2. So if you had after that operation, so here you're checking if it has value, if it's not null, you say previous dot next equals to current 2. So current 2 being hii node yenye ulipata yenye iko at position 2. Else hii previous one kasi ni null, it will mean that hiyo ndio the like hiyo node yenye sasa unataka uswap, it will mean now the node at position 1 is the head, so ndio maana iko na previous one iko null. So you make now the head, the self.head point to current 2, now the node at position 2. And then you do the same for if previous 2, like now the node that is before the node that's at position 2, unaifanya sasa point to the node at position 1. And then if now the previous node like the previous node before the node that's at position 2 iko null, it will mean that the node at position 2 ndio ilikuwa the head. So you go ahead and make the you go ahead and make the head now hold the current one node, right? And in the end hapo utapata usha swap. Okay. So now we go ahead and now I think we may go through most of the basic operations. And now I'm welcoming room for questions. Niwape dakika ngapi? Mmetayarisha maswali?
Said you can give us your site.
Hello? Hello, is there any question? Are there any questions? This one. Are there any questions?
Inakaa ni kama we don't have any questions, so we can end the session there. I hope everyone is good there.
So, wrapping up, so the things we've discussed so far, the various types of linked lists and basic operations of linked lists on linked lists. It's been a pleasure doing this, and thank you guys for your time. So it's a wrap for me. Naona saa 2:30 imefika, masaa ya kuondoka. So thank you guys. I'll share the resources with Sage, alafu mtazipata kwa group. Sage, naambiwa utufungie na maombi.
Time bad.
Sawa. So it's a wrap, guys. Thank you for your time.
It's
It's
a
my
wrap
first
kama
time
nani.
doing this. So asanteni sana. Good night, everyone.